These are our ratio table notes. So we're still talking about ratios, and our table is just a way to organize our thinking. So ratios still show a comparison between two values. One way to organize these ratios is to make a table. And all of the ratios in the table are equivalent. So if we are creating equivalent ratios, we can still only use the two operations. We can still only multiply or divide to create equivalent ratios. And a reminder, whatever you do to the top, you're going to do to the bottom. These notes have an explore activity that goes along with them, but we're just kind of going to fill in the information so that you kind of understand where it's coming from. So the first ratio they give us is about this duck, and they tell us the duck weighs 56 grams, and it takes 4 balloons to lift the duck. So we have to figure out, how do you turn 56 into 4? Well, the first thing to think about is we got smaller. So between multiplying and dividing, which operation makes numbers smaller? And that answer is dividing. So we're going to have to divide 56 by something to get to 4. So over here, we're going to have 56 divided by 4. 4 can go into 5 one time, remainder of 1, bring down to 16. And then how many 4s go into 16? That answer is 4. So that means 56 divided by 14 would equal 4. Since we already established that the table is showing a bunch of equivalent ratios, that means our rule is to divide by 14. So 14 divided by 14 is 1. So it's going to take 1 balloon to lift the sandbag. And we're going to apply this all the way through, because whatever you do to the top, you do to the bottom. So here we have 350. We're going to divide that by 14. So squishing that in over here, 350 divided by 14, 0, 2. 2 feels right. 2 is right. Okay, so minus 28. You're left with 70, and that's 5. So the bear would take 25 balloons. Same thing, whatever you do to the top, you do to the bottom. So 98 divided by 14 is 7. 112 divided by 14 is 8. And 70 divided by 14 is 5. So we can use the same rule because all of these ratios are equivalent. So over here, it says to write an equation to show the relationship between the weight of the item and the balloons. So basically, how are we turning the weight into the balloons? And to do that, we took the value, or the weight, and divided by 14, and that gave us the number of balloons that we needed to float the item. If we were given the balloons and asked to find all of the weights, we would just do the opposite. So the opposite of dividing is multiplying. So we would take the balloons, multiply it by 14, and that would give us the weight of the item. So again, with equivalent ratios, you can only multiply and divide. Whatever you do to the top relationship, you have to repeat to the bottom relationship to keep them equal. So here's some different types of table problems, and each of them is asking us to find missing values. So for pizzas per student, the first ratio, or I guess our starting ratio, is 2 pizzas for 9 students. And up here at the top, we're turning a 2 into a 10. It's reading bigger, so we're going to multiply. And 2 times 5 equals 10. Whatever you do to the top, you do to the bottom. So 9 times 5 is 45. Then I want to turn 45 into 450. We got bigger again, so we know we're going to multiply, and more specifically, multiply by 10. Whatever you do to the bottom, you do to the top, and 10 times 10 is 100. So again, the ratios in ratio tables are all equivalent, so it's just about finding the rule to go from your starting ratio to the next. Okay, in example number 2, John is mixing green and white paint to make his favorite shade of light green. The table below shows his ratio of green to white paints. Fill in the missing values. So this one only gave us one ratio to start with. So we have to start with this 15 to 25. So we're going to scale down to 5 first. So if I go from 25 to 5, I got smaller, so I have to divide. And 25 divided by 5 equals 5. Whatever I do to the bottom, I do to the top. So 15 divided by 5 means we would need 3 ounces of green paint there. If we start going in the other direction, we're still going to start with our starting ratio of 15 and 25. So if I want to turn a 15 into 30, I got bigger, so I'm multiplying, and I'm specifically multiplying by 2. Whatever you do to the top, you do to the bottom, and 25 times 2 is 50. And then for our last missing number, same thing. We start with our starting ratio of 15 to 25. We're turning 25 into 75. So we're getting bigger. So we're going to multiply. And more specifically, we're going to multiply by 3. Whatever you do to the bottom, you do to the top. And 15 times 3 is 45 ounces of green. So again, your ratio tables are a way to organize a bunch of equivalent fractions. You always have to apply the same rule to the top and the bottom. And you're always looking for missing values. My advice would be to make sure you start with the completed ratio given. So down here in this second example, I started with 15 over 25 because I didn't make a math error when getting those numbers. Those numbers were given to me.